Hello, my name is Alan Teixeira. I'm a PhD student at the University of Campinas, and I'll be presenting the demonstration titled Programmable Network Testbed for QoEs and QoE Assessments of Holographic Media Delivery. We developed a testbed composed by a main point cloud video server running Nginx, where point cloud dataset is stored. This server is connected to the Tofino programmable switch, in which we applied the P7 emulator with 6 emulated nodes. Two of them represent distinct edge networks, Edge 1 and Edge 2. The Tofino sends data to the access point that connects to the user's head-mounted display. The transmission architecture is configured as follows. The storage point cloud files are encoded by the Google's Draco compressor once the Nginx server receives the GET request. Then, the compressed files are sent into the Tofino programmable switch. Using P7, distinct network metrics such as packet loss and latency can be inserted at the emulated switches SW1 and SW2 to represent different edge network behaviors. After exiting the Tofino and passing through the access point, the packets reach the MetaQuest 3 running a fully immersive application developed using Unity Engine embedded with Google's Draco, where the point cloud is to be presented. Google Draco decodes the packets and then the projection of the point clouds is performed by the application. The demonstration features two screens. The left screen represents the Tofino BF shell with packet flows on the top and the P7 configuration at the bottom. The second screen illustrates the performance of the holographic video the user is watching at the head-mounted display. For different scenarios, the user will be experimenting different quality of experience levels. This is the first scenario, and the ideal scenario, with no packet loss and no latency is applied. As you can see, the holographic display performance is pretty smooth, with no stuttering or crashes. Additionally, both the application frames per second and the animation frames per second remain stable throughout the session. Next is the minimal packet loss scenario with 0.1% of packet loss. In this scenario, the animation remains good and the changes are almost imperceptible in terms of frames per second and the smoothness of the animation. Next scenario is moderate delay with 4 milliseconds of delay. As one can observe, in this moderate delay scenario, the quality of the animation starts to decrease with eventual breaks on the fluidity. Next is the high delay scenario featuring a delay of 10 milliseconds. This scenario is critical for the user's quality of experience. Here, the animation smoothness is compromised, making it difficult to observe the sequence of the holographic animation. Then there is the scenario with low packet loss and high delay. The packet loss is 0.1% and delay is 10 milliseconds. In this scenario, it's practically impossible to experiment at the slightest quality whatsoever. Besides that, the frames per second rate dropped to the record low in this experiment at 50 frames per second. Finally, the last scenario is the high packet loss scenario, featuring 2% of packet loss and no latency. In this scenario, the smoothness of the video has improved significantly in comparison to the last two, including the stability of the frames per second. However, the quality of experience is lower than the first two scenarios. We aim to refine holographic transmission designs aiming QoE assessments for HTC with P7 by leveraging dynamic network slicing and in-band network telemetry. Our group would like to thank Unicamp, FAPESP, and Ericsson for the support.